Hello, folks. Here on Answer Everywhere, we're taking a look at Meterpreter, or the repo that used to be called Meterpreter. I think the shell is still called Meterpreter. This was a request. This was a viewer request. We're doing requests once a month. They're being based on donations. This particular request was, they sent a donation of $20. It was a long time ago, and I think it was in a chat during a live stream. And YouTube deleted the transcript for it, so I couldn't find it for a while, but I was able to track it down. And so I'm happy to now present Meterpreter. We have looked at the Metasploit code in general before. That's a Ruby code base, and it does kind of all of the things you would expect Metasploit to do. It has some collection of attacks, and it has some framework for scanning, running a known exploit, etc. And so, I guess the next stage, after you have managed to find a vulnerable system, is that you want to run a shell. And that's what Meterpreter is about. So this repo has various payloads that used to be in different repos. So we have the C Windows Meterpreter, Java and Android Meterpreter and payloads in Python and PHP Meterpreter. I'm going to focus on the C Windows one because I think that's the flagship shell. Okay, so we're going to be working mostly in C, 64.9%. And then there's some C++. And then I'm guessing that Java and Python are mostly the other sub repos. And basically, what are we doing? My understanding, I'm not a tacky security person or penetration tester or anything, but my understanding is that we're essentially just using DLL injection, and we're going to inject a small shell into the attacked machine, and that will give us the ability to run commands. Some of those commands are FTP-ish sort of commands, like upload and download files. Some commands are things like scan for a web camera and take pictures from the web camera, and probably similarly for audio. And for all of this stuff, you can find lots of tutorials on the internet. There are some on YouTube. There are probably lots on Medium, if Medium is still around. There are probably lots on whatever, Substack, which I think is trying to be the new Medium. But there's no shortage of information about how to set up a VM to do all of this and test it. I'm not sure where to start. We have deps. These are dependencies. I don't think there's much here. We have LibreSSL. I don't know why they're using LibreSSL and not OpenSSL. And maybe there's some git blame thing that will tell us. I guess we need to have a specific file to blame. Replace OpenSSL with LibreSSL. So where's the? It doesn't say why. It doesn't seem to link to a bug report that says why. But for some reason they don't want OpenSSL. Okay, so I guess most of the goodies are probably in source. And we have common, def, dump Sam. Sam, I don't remember what that is. I think that's possibly a Windows thing, but I think we're going to dump something. We have elevator, extensions. Elevator might be privilege escalation. JPEG 8 might be just JPEG support. So for things like web cameras and stuff. We have logging. We have metserve, which might be the server. MingW is it the compiler? An implementation of the GNU toolchain for Windows. Okay, so it's the GNU toolchain for Windows. I'm guessing we're going to use that for some of the shell commands. Things like ls, change directory. We also have, and then we have screenshot, presumably for taking a screenshot of the attacked computer. And doxygen should be for documentation generation. Tiny regex should be for regular expression support. And that doesn't leave a lot here. That's elevator. Did I open up common? I assume this is referring to the wrapper common. We also have def. I didn't open up some of these. Def might be things like includes. I don't know what. So dump Sam. So what is the SAM file? It does seem to be a Windows thing. Something about credentials. Oops. Is it like the users file or the password file or the group file? The security account manager is a database file in Windows XP, Windows Vista, Windows 7, 8.1, 10, and 11 that stores users' passwords. Hopefully not in plain text. They're stored in a hashed format in a registry hive, either as an LM hash or as an NTLM hash. LAN manager. I think I found when I was looking at the Metasploit source code, which was many moons ago, that they had a way to reverse LAN manager hashes. So I don't know if that was just brute force search of a huge hash space or if those hashes are bad. NTLM is a challenge response authentication protocol, which uses 3 messages to authenticate a client in a connection-oriented environment. Okay. So that's, I guess, a Windows NT thing. All right, so we're not going to look at dump SAM right now. Here's common. And here's def. Extension.def, metserve.def. This is maybe just... I don't think this is just human readable. I think this is telling us something maybe for a build system. Reflective loader, @1, no name, private. This is something maybe about DLLs in Windows. I don't know anything about Windows. At any rate, that doesn't look like the most cool stuff. This looks like it's maybe the most cool stuff. So what do we have to do? We have to have a shell that's small enough to inject in a process, like a running process. It needs to provide enough functionality to do things. I assume that for the most part, we're just sending commands like upload, download. If we really, really want the shell to be small, it's possible that we could send the implementation of those commands rather than embed them in the DLL thing that has to go in memory. But I'm going to guess that we're not doing that. That would result in like more network traffic. What else do we have to do? I think we have to. There has to be some support for, I think, migrating from process to process. I don't know really how that works. If it's using existing Windows API calls, or if it's using exploits to do privilege escalation. But let's find out. Okay, so here's common. We have common base, common channel, common command IDs, common config, core, exports, list, logging, met API, pivot tree, remote scheduler, and thread. All of these could be cool. I forget what I was saying, but we'll look at common. We'll look at common base. These are probably just going to be really simple base classes. Common exports is maybe not so important. The scheduler and thread are probably interesting. Pivot tree, I'm not really sure what a pivot tree is. That might be a data structure. Common core and common config and command IDs. So these are all includes. Where are the implementations? Unless this is like a header only situation. And then in extensions, we have a bunch of stuff like LAN attacks, PE injector, PowerShell, priv, Python. I'm guessing might be just like Python interpreter support as opposed to just a directory full of Python stuff, but maybe we'll just take a quick look at it. Sniffer, I'm not sure. Unhook, I have no idea what Kiwi is or incognito or a Boffle loader. We'll look at a few of the extensions. I think I opened the elevator file, but now I kind of want to look at it just before we spend too much time on the common stuff. We'll look at the header in elevator.c. And maybe token stuff, named pipe service. What else do we want? Metserve. I'm thinking Metserve is probably just mainly the server. And I think it's going to be relatively simple. It has to be small and lightweight. It only needs to communicate with a single client. And the client and the server both know what they're doing. So you could use something like RPC. You don't have to use something like the whole purpose of something like REST, a REST API, is that the client and server don't have the same implementer. So the client, the API needs to be flimsy enough for it to be like discoverable, or the client can figure out what to do. But in a situation like this, the shell and the server have the same implementer. So that saves you a lot of headache. All right, so on to common.h. I'm just going to quickly scroll through this because I want to see what their C style is like. We've got a bunch of undefs to avoid conflicts with Windows Crypto API defines. Okay. And we've got this huge thing. Is this all one if def? I think so. This is some debug stuff. We have this break on error stuff. Sets DW result to the return value of get last error, prints debug output, and then does break. I guess this is mostly for debugging. This is basically printf debugging, which I'm a big supporter of. Then we have real dprintf. I'm guessing the D stands for debug. Output a debug string to the debug console. And then we just include a bunch of other stuff from common. So this is mainly debug printing this if def, which is if def, which is also debug related, and the not wanting to conflict with Windows Crypto APIs, and then include. So there's not much going on here. What about in common base? This looks like an interesting macro. It's a brief helper macro that defines a command instance with a request handler only. Remarks, I guess remarks is like part of the doxygen stuff. The request handler will be executed on a separate thread. So we give it a command ID and a request handler, and it has an implementation, which is just, we're going to write the command ID in this tuple, request handler null empty TLV, and then we've got this empty dispatch handler. Empty dispatch handler is here, null empty TLV. And I don't even, okay, so this is, I'm not sure what you get by putting command ID here. This doesn't seem like a valid line of code. Let's ask ChatGPT about this. So what's up with this macro? A structured initializer. Yeah, unique identifier. I'll say show some example code it will generate. Isn't that? I think it probably is a struct and a struct. A struct and a struct. Yeah, that's probably right. Thank you, Casper. I don't know. Yeah, that's a good point. I thought it was going to define a function. I'm expecting it to define a function, but I guess it's just going in a struct somewhere. Yeah, okay. Awesome. All right, so then we have command rep that defines a command instance with a response handler only. Command instance versus a command. Okay, so as opposed to having both a request and a response handler. The request, well, hang on. With a response handler only. The request handler will be executed on a separate thread. So you give it a command, you give it a command ID and a request handler, and it makes this thing. Except we give it empty dispatch handler for the request, and we have an implementation for the response. So it's just this thing has moved places. I'm not sure. So you're sending it some request. I'm assuming it's the server that's handling the requests. And I guess maybe the response stuff runs on the client side. It doesn't say, but at any rate, it's executed on a separate thread. And then there's another one for request and response. So we're just kind of filling out some struct. And here is probably the struct in question. Defines a command handler for requests and responses. We have a dispatch routine, a pointer to the routine that will be called to handle the request/response. Some handler, an inline dispatch routine, a brief pointer to the routine that will be called on the current thread. If this function is specified, it will be invoked on the current server thread rather than a new thread allocated to it for processing. The result of this routine will indicate whether the server should continue. If this value is specified, i.e. non-null, then the /c handler value is ignored. Okay, so this is it's called an inline handler. I guess it means inline in the sense of running on the current thread. And then we have some types that match the expected arguments for this response request routine. So you may expect a string and return an int or something like that. I don't know what TLV is. Type, I don't know, TLV something. And then we have the number of entries in the argument types array. I'm guessing C is maybe a documentation thing, like to highlight it or link it or something. Okay, so how many argument types do we have? And this is a packet dispatcher. And then here's the struct command, which has the command ID. So this is the thing that's generated by those macros. We have the command ID. We have a packet dispatcher request, which is the request handler. We have a packet dispatcher response, which is the response handler. And then we have internal stuff, which is some linked list that is not stored. I would still like to know what a difference between a response handler and a request handler is. Let's look that up. Response handler. All right, I'm not finding anything, but we'll find out more as we go along. So here's common scheduler. Is there something better that we should look at next? I guess we'll look at scheduler. We just have some enum that's whether to pause, resume, or stop, and that's some scheduler signal. And then we have this thing, waitable notify routine. This is a type definition. It's got a pointer to the remote thing. Whatever LP void is, some version of a void argument, I would assume. It's got an entry context and a thread context. I don't know. And then similarly for waitable destroy routine. I think there's no common scheduler implementation, is there? Maybe it's just imported by the different implementations. Yeah, I don't know. But we'll move along the thread. So we have not much here, it looks like. We have this lock. I don't know what LP lock is. I don't know what LP is in general. But we saw it in the other file. And what are you doing? No, don't do that. And maybe it's Windows. Maybe it's specific to this thing, Windows LP lock. Is Google also just going to start ignoring my search terms? This is like the new trend. Okay. I think that nothing is coming up. But I bet if I do Meterpreter, it will come up. Nope. All right. I guess search engines are dead. I can search the repo, LP lock. Oh, wait. No, this is just defining the thing, right? Okay, so we have this struct that's locking. We have events, which also have the LP event stuff. And what else? We have this thread thing, struct thread, which has an ID. I'm guessing just a thread ID, a handle, an event, which is which is I guess called sigterm. I don't. Isn't that the terminate signal? Long pointer. Yeah, thank you. That's probably right. That sounds right. Thanks, Casper. Yeah, okay, so we have dword pointer and LP rect. All right. Okay. Okay, so sigterm signal is sent to a process to request its termination. Okay, so I don't know why get that out of here. I don't know why sigterm why this thing is called sigterm. I think I'm remembering structs correctly, right? So this is the type, event star, and this is the name. Then we have thread func, which is maybe like a, I was going to say it was like a thunk, but maybe it's like a function. And then we have whatever LP void is, I guess a long pointer void to parameter 1, parameter 2, and parameter 3. Maybe this is like if you receive a sigterm, this is like recording which event sent it to you or something. Perhaps so you can capture and ignore sigterms from people who are trying to prevent you from being malicious. We have this common pivot tree, which has some pivot context. I still don't know really what we're doing, but now we know that thanks to Casper that LP is long pointer. What was it? Long pointer. So we have a state, a raw packet, and a raw packet length. And then we have, that's a pivot write packet. It has some state, so it looks like maybe we're building up a state machine. The raw packet and the length, we could just consider this to be one thing. And then we have pivot remove, which has some state. And so the pivot context is we have a pivot write packet, which is this thing with some state. We have the pivot remove, and then we have, I guess, what state are we actually in, perhaps? That's the pivot context. And then we have a pivot node, and we're building up, I guess, a tree of pivots. And maybe it's like a decision tree that tells us what to do as we get packets. And we have a head. Pivot tree is just a pointer to the head. Although I guess it could be it shouldn't be a list of heads. I feel like a tree should have at least 2 descendants. But I guess that's what we have. And then we have this pivot tree traverse callback, which takes a GUID, maybe like as an ID for the callback. It takes a context and it takes some state. Let's see if this is doing something. This looks kind of like filtery pen testing guide pivoting. Let's say you have compromised one machine on a network and you want to keep going to another machine. You will use the first machine as a staging point. /plant/foothold to break into machine 2. This technique of using one compromised machine to attack another is called pivoting. Okay, so I guess this is maybe like routing. In Metasploit, Meterpreter, what is a pivot tree? I'm guessing it's basically routing from the one compromised machine possibly to the other machine, so that the packets seem like they're coming from inside of the compromised network from a trusted machine. A pivot tree is a structure used to manage network pivoting, a technique for accessing and attacking internal networks that would otherwise be inaccessible from the attacker's initial position. Okay. This is about pivoting the tree structure and pivoting. The tree represents the hierarchy or chain of pivots. The root node is typically the initial compromised host that has direct access to the attacker's machine. And then we have branches and nodes represent subsequent pivot points. And it enables organized routing of traffic so the attacker knows which host to reach specific blah, blah, blah. In Metasploit, the route command is used to add routes for pivoting. Okay. That's fine. It doesn't really explain why we don't have what appears to be a tree structure. But I'll ask ChatGPT again. So why do we have, in the pivot tree struct, why do we have a pointer to head, but no apparent branches? It's a lengthless structure rather than a traditional hierarchical tree. Okay. Despite its name, the pivot tree here is more like a single chain linked list. Okay, I guess there's nothing else you could really do with it, right? The pivot node might... Where's pivot node? Did we not see it? Yeah. Okay, it's in metserv as opposed to common. So the pivot node has a GUID, a pivot context, and a left and right. Okay, so there's the tree structure. It's just not in this folder. It's in another folder. Fine. So logging, this is not so interesting. We have init, get, logging, get, etc., etc. Common meta API. This looks like the actual API. So I don't know if these are commands. We have this DLL thing, which takes in a DWP ID. So presumably process ID, DW, I'm not sure. Maybe for D word. DW destination arc, presumably architecture and LP DLL buffer. I'm guessing is maybe the hello R. I'm guessing this is just the DLL, like serialized, its length, whatever a reflective loader is. Some args and the size of args. And then we have an APC thread. I don't know what APC thread is, but we have a remote thread, which is presumably the remote thing that you're either injecting into or using to inject. It has some pointer to a remote. It has some packet for a response, some handle, destination arch, etc. And then we have the channel API, which has methods like exists, is interactive, is flag, create diagram, find by ID, close, get class, open, write to buffered, and so on and so forth. Okay, so this is the API. This looks like a cool place to get a sense of what they do. Thread API, you can destroy, join, kill, sig term. A scheduler API, you can initialize, destroy, insert waitable. I'm guessing the scheduler API is mainly for scheduling the different threads, which is why it's relatively simple. Simpler than like an OS scheduler would be. This is the packet API. TLV. Top level value. Total list. Voltron. Type length value. Okay. So I'll read this later. So in communication protocols, type length value or tag length value is an encoding scheme used for informational elements. A TL value encoded data stream contains code related to the record type, the record's value's length, and finally, the value itself. Is that like ASN? Oh yeah. ASN.1 specifies several TLV-based encoding rules, BER and DIR, as well as non-TLV-based ones. I don't know if you've ever worked with ASN1, but it's pretty terrible. So draw an image of an engineer working with an ancient ASN.1 protocol that they are reverse engineering. Think through what it's like to work with ASN1. Then describe that experience in vivid terms, and then generate a Dutch master style painting of the experience. I told you to think first. I'm just going to go into generating the image. Oh, fine. Okay. Capturing the depth and mystery of working with an ancient ASN.1 protocol, piecing together the cryptic puzzles in the dim candlelit settings. What do we think? Is this right? Yeah, I mean, that's not bad. Okay. All right, so TLV is type length value, I think, or tag. I think there were two different expansions of it. But we have the type of the thing that we're sending, how long it is, and what its value is, so that you can parse it in a pretty naive way. And we have things like add TLV bool, add TLV group, keyword, string, call completion handlers. Enum TLV. I'm guessing that's the enum type and not enumerating the existing TLVs. You can get the TLV. You can transmit empty response, transmit response, create group, etc. I don't know what an empty response is. And I don't know how you can transmit something empty. Maybe it just has no values. Maybe it's just like the metadata. Maybe it's similar to an ACK where it's like a specific value that has a meaning and the meaning is empty. And then we have a command API. You can deregister all, register all, handle. Okay, so it seems like once we have the Meterpreter shell, we are like registering commands. So the payload thing, the DLL. Oh wait, hang on. Yeah, so the DLL itself doesn't have necessarily all of the commands, or perhaps it has a core shell of commands, and then this is just for registering additional ones. But I guess in order to even call the method, this DLL injection thing, we I don't know if this takes place in Meterpreter itself, and then you go into like a subshell that's like the attack subshell, or if this takes place in the general Metasploit framework and this sends you into Meterpreter. Because we could be a couple of things deep. I think that what happens is that like the Meterpreter shell has like a what's the word? Like an ambient layer, and then you perhaps go into a specific attack, and then like you leave that attack and you do things like clean up or something along those lines. And we have an API for listing. You can add, clear, enumerate, push, remove, count, get, pop, shift, and destroy. And so if you're wondering what's life like before like CRUD apps, you might have a list API that's not like a CRUD REST API. And it might have different things like removing, at, create, get, pop, shift, destroy, and so on. So that's cool. That's APIs. But let's see what else. I want to see, well, I don't know. This is all pretty useful, I think, for understanding what they're up to. So here's some of the TLV stuff. Like these are the different types, and they are just bits, and they're defined like this. We have load flag on disk indicates that the library in question should be stored on disk. Okay, so you might, I guess, upload your exploit, I assume, first. This indicates that the library in question is an extension library. Extension libraries have init server extension and deinit server extension functions, which need to be invoked. I'm guessing it means like a Meterpreter or Metasploit extension, rather than like a Windows extension thing, whatever that would be. There might be a library that exists locally. These are different flags you can set. And then we have an enum of the types, full list of recognized TLV types. So this is kind of defining a protocol. We have a migrate technique, library path, target path, migrate PID, and it represents the process identifier of the migration target, right? I hope that was going to say migration target. What? Oh, did I somehow? What has gone on, GitHub? Well, wherever I was, I think it was going to say migration target. But now we're somewhere else. Here we are. The migration target, unsigned integer. Okay, so this is for migrating. You know, you have attacked some thing. Maybe it's not an important app. Maybe it's not running as administrator. And I think that this is for like, okay, now we want to move to some Windows process or something that is running as administrator so that we can have root access. And we have a migration payload, presumably the payload that you're going to do on the migration, the PID you're going to migrate to, and so on. And we have transport switching. This is maybe for switching between transports. So we have HTTP. I guess HTTPS, I don't know if that counts as a different transport. But we can probably like grab this and see the different instantiations of it. Maybe. What was it called? That's pivot nodes. Trans type. Although I think this is just the yeah, here we go. This in metserve.h, we have different things like HTTP, HTTPS, pipe, using named pipes, and TCP. Okay, so those are the transports. So we'll get to the metserve stuff soon. In retrospect, we maybe should have started there, but this common stuff is also useful too. And then we have channel types, etc. Packet encryption, like pub key. I guess you could use public key encryption, symmetric key, and we have the pivots, and you send that information onto the machine. We have a packet header, which has an XOR key, maybe for stream cipher. We have a session GUID, enc flags, and probably either encoding or encrypting. I don't know which one is which, and then a length and a type. We have the TLV, which is just a header and a buffer, and a packet, which has a payload, which is a PU car, pointer unsigned car maybe, and some decompressed buffer, whether it's local, like a non-transmittable packet. I don't know what that's for. And some packet request completion stuff, which has a context, a routine, and a timeout. Okay. Here at the command ID, here's the command ID header. I Things like add, change, get, cert, hash. I don't think we've seen those before. Negotiate TLV encryption, we haven't seen before. Channel interact, channel open, doing different things with channels. FS separator, probably maybe like file system. We also have like mount and show. Okay, so this is now starting to look like commands like you would like POSIX commands that you would run. So MD5, I'm going to guess computes the MD5 hash. That's not really super POSIX, although there is the MD5 sum utility. But we have things like ls, which is presumably going to list the files in a directory, get working directory, file copy should be just copying, change directory, change mod, chdir, chmod, and so on. So these things are at least defined here. So if you want to change directory, you're going to send 1001 as the command. And really, everything that's in the shell has to be here. Like webcam, audio record is 1110, and get frame is 1111. And so if you didn't have, what's it called? Like a checksum, if you didn't have like error correcting codes and one of these bits gets flipped, you might try to make a directory or something and end up controlling their webcam. But this is all taking place over transport and whatnot that has checksums. So that probably doesn't ever happen. But these are the commands. And then event log clear, I think event log is what they call the, as you log into the computer, you do nefarious things, and then you clear your tracks. And I think the event log clear is the thing that clears your tracks. Window enum, I don't know what that is. That might enumerate the windows. You can incognito impersonate token. I don't know if that's like browser incognito or something else. There's some PowerShell stuff here. I guess PowerShell execute is presumably execute in a PowerShell, and so on. So these are just the names of the commands. We don't have their implementations yet. This is the priv extension. This is the Python extension. Let's see if we have a README. This is Python version 2.7.10, which I think is like way deprecated, isn't it? Python main. Is this the implementation of Python? Initialize the server extension, API pointer to Meterpreter's API structure. I think that, so this is Python main.c. I'm guessing that this is, they took the C Python and are implementing it with a like Meterpreter wrapping. But I'm not positive. Let's look at one of these like subprocess. Support routines for subprocess module. Currently, this extension module is only required when using subprocess module on Windows. Yeah, this looks plausibly just like regular Python. So I'm going to guess that's what's going on. This is just Python where like the main file is perhaps aware that we are in a Meterpreter shell. Priv, I don't know. Look at priv.h. Priv. Or maybe we can look up the documentation. Okay, to make use of the get system command, if it's not already loaded, we will need to first load the priv extension. Use priv. Loading extension priv. Success. Okay, so this is going to privilege escalate, but the question is how? We've got a bunch of TLV stuff. This, I think, is just mainly about communication. We've got SAM hashes. Presumably, we're going to somehow get the SAM file and maybe brute force it. Is that possible? Priv.c. And what? Elevate get system, request password get SAM hashes. So we are going to get the SAM hashes. We're going to request the fs get local mace. I don't know what a mace is. This is init server extension. We're going to register. Okay, so here we're seeing the registration stuff. Okay, so we have the met API, blah, blah, blah. It's going to take this API object and the remote, which is a pointer to the remote instance. We'll set the logging context, I guess, according to whatever the API says. And then on the met API, we're going to call command register all custom commands. So this API is really just the thing that has like a client and it communicates with the hacked machine or whatever. And then the custom commands are defined somewhere here. And I'm guessing elevate get system is the one I want, right? Does that point to a function that's an implementation? Here. Attempt to elevate the current Meterpreter to local system using a variety of techniques. This function attempts to get system level privileges using a number of techniques. If the caller hasn't specified a particular technique, then all of the known techniques are attempted in order until one succeeds. Okay, great. So this is about as simple as I think as you could do. We have some sense of how to do privilege escalation on Windows. That sense is kind of built up by scripts. I'm sure that when somebody publishes a new attack or whatever, that will get implemented in some scripty way. And this is, I think, conceptually just going to be like a for loop. And we're going to try each one until it succeeds. Hopefully we're going to try it in some order, like this attack frequently succeeds, so we'll try it earlier. And this attack very rarely succeeds, so we'll try it later. And as opposed to like alphabetical order, but I don't know. So we'll look at this code because it will give us a little bit of insight into how we're using the API that they've set up. Okay, so by default, it looks like we're going to set a result to bad arguments. And the technique will be elevate technique any. And the packet response is null. Then we're going to call create response for the null packet. Although, I guess you're passing it in. No, okay. So, sorry, response is null, packet is passed in. So, we're going to create a response for the packet. If there's no response, we're going to break with error. And then we'll say it failed. Otherwise, we're going to get the value of some TLV, namely the technique. And then we'll say we requested this technique. And if the technique is try anything, or it's named pipe, then we're going to try the named pipe thing. Elevate via service named pipe. So I guess if it's any, that's the default, is named pipe. Or no, I guess everything starts, but this is the order, right? So we'll try named pipe, then we'll try named pipe 2. And we'll try the elevate technique service token dupe. Maybe like duplicating a service token. And then so on. We'll try it with named pipe RPCSS. Print spooler. Named pipe print spooler. I guess maybe there's some print spooler exploit and so on. So let's grab the first one here. Elevate via service named pipe. Elevate from local admin to local system. From local admin to local system via named pipe impersonation. So I guess we're starting as a local admin. I don't know what local system means. It seems like the reverse of a escalation. But I think I just don't know what local admin and local system mean in Windows. We spawn a command.exe under local system, which then connects to our named pipe, and we impersonate this client. This can be done by an administrator without the need for SE debug privileges. It works on 2000, XP, 2003, and 2008 for all local administrators. On Vista and 7, it will only work if the host process has been elevated through UAC first. It does not work on NT4. Okay, so this tells us what we're going to do. We're going to spawn a command.exe under local system, which then connects to our named pipe. I'm going to send this to ChatGPT and ask them what the difference between local admin and local system is. And we're going to do this in the Meterpreter one. So in this paragraph, what's the difference between local admin and local system? So there are different privilege levels in Windows. A local administrator is a user who has administrative privileges on a particular machine. However, blah, blah. So they're restricted to permissions of the administrator account and are lower than the full privileges held by the system itself. The local system account, also known as NT authority / system, is the highest privilege level on a Windows system. It is an internal account used by the operating system to run system services. Okay. So the administrator is like a human administrator account, and then the local system account is maybe more like a robot super user account. And I always forget which ones are which, forward or backward. Okay, so the backward slash is the one that is weird, and Unix uses the forward slash for, I guess the forward or backward refers to the top, where the top of the slash is and not the bottom. Okay, so this escalation is just done through a named pipe. Why is this possible? Let's see. So we define some variables up here. This is just set up. We don't need to look at that. This is just like communicating. This is maybe just, I guess, setting up the name of the pipe. And we're going to command.exe echo into the thing. Oh, okay. I guess this is possible because you can, the human can do a bunch of stuff. And among the things it can do is just execute a command. The command will run as the system, I assume, if it needs sufficient privileges. And then one of the commands you can ask for is just to have an interactive shell or something along those lines. Maybe a little bit like on Ubuntu or something that disables the root user. You can still like sudo bash to get a full shell, as long as you have sudo privileges. I'm guessing that's kind of conceptually what's going on. I'll ask, why is it possible to escalate from local admin to local system? Is this a bit like running sudo bash to get a shell even when the root user shell access is disabled? Yes, it's somewhat similar in concept to running sudo bash. So here is how and why this elevation is possible. Local admin permissions are high, but not absolute. A local administrator has significant control over the system and can manage settings, services, and user accounts. However, local admin does not have access to certain kernel level resources. And so it has mechanisms like named pipe impersonation or token duplication, which can allow a process running as local admin to impersonate higher privileged accounts under certain conditions. Why does Windows allow this? It relies on user roles and security tokens to manage privilege levels. Local admin accounts already have access to many high privilege services. Okay, so it exploits the ability of local admin users to interact with system level processes. Okay. So later they used user account control and least privilege model to attempt to mitigate these risks by adding more barriers. Yeah, I think that some of this is maybe unavoidable, and so that kind of makes this seem like it's not an especially interesting attack if this is just something that Windows enables. And to execute it, you have to be admin, which is like the highest level user there is. Let me just verify that. Is there a higher level user account than local admin? Okay. So I guess I was wrong. I guess local system is not a robot account. Used by the service control manager. So you cannot specify a name. Its name to call the lookup account name function. It has extensive privileges on the local computer. What is the this account is not recognized by the security subsystem. So you cannot specify its name in a call. Used by the service control manager. Okay, so we'll read about this. We'll read about the service control manager. I think the service control manager is an app, right? And not a person. Okay. Draw a vivid image of the local administrator. Is that what it's called? And the local system accounts facing off in a battle of power and magic. I'm always tempted to switch away while it's waiting, but then I realized I've forgotten to switch back several times. Okay, so here's the local admin and the local system. It seems like the local system is actually more powerful. It actually looks a little bit more evil. The local admin looks a little bit clericy and like blue and like hopeful and good. And then the local system account has like this like fiery look. Like it's like a fiery undead demon. So I guess that's how things work. All right, so that's escalation. I'm sure there's more to it, but let's see. Maybe we'll take one of these and see if there's anything that doesn't require you to be an admin. It seems like perhaps we have to already migrated maybe to a process that has admin rights. Elevate via named pipe EFS. This doesn't have a comment on it though. Let's ask maybe Gemini. So tell me about the priv extension in Meterpreter. Do you have to be already a local admin to escalate, or can you escalate from local user, whatever that's called, to local admin using the priv extension? It's a powerful tool. In some cases, the priv extension can be used to escalate from a standard user to a local admin. This is typically achieved by exploiting vulnerabilities in specific applications or system services that allow privilege escalation. I'm not sure this is entirely true though, but I do get a URL. This is just a what is privilege escalation. How about Meterpreter priv escalate from user to admin? We'll just do a web search. I don't know. I don't think I'm going to be able to find this quickly. Frequently, especially with client-side exploits, you'll find that your session has only limited user rights. Maybe I will find it quickly. Get system, which will use a number of different techniques to gain system privileges. Okay, so that's what get system means. It means get system privileges. Okay, this can severely limit access. You could blah, blah, blah. So you can get UID, get system. If it is not already loaded, we need to first load it. Running get system with the HSys switch will display the options. So it says in memory /admin. But what does that mean? Here's a blog post about what happens when I type get system. So technique 1 creates a named pipe from Meterpreter. It also creates and runs a service that runs command.exe, blah, blah, blah. When spawned, command.exe connects to Meterpreter's named pipe. Meterpreter has the opportunity to impersonate that security context. I feel like get system elevates you from local administrator to the system user. Okay. It seems like you have to be admin first. So if that's not right, you tell me. But I don't know how you get to be admin. Maybe that's just from the process migration. Unhook. I'm going to not care about unhook. Elevator. This has the named pipe stuff, the token duplication stuff. The header didn't seem to have many comments. Let's look at the C file. Is this where we ended up? Elevator command dword. Grab dword value. Elevator command int. This seems to mainly be focused on communication. Elevator main. Okay. That's token dupe. Named pipe service. This is a channel thing. This is for metserve. We haven't really looked at metserve, but let's do that now. We have base inject H and C. We have channels. We'll just make sure these are all open. List met API. I think I guess, might as well look at this stuff. Encryption, I think I'm going to ignore. Pivot packet dispatch. Should we look at? Maybe. I'm not going to spend much time on that. Remote, this is mainly going to be like a pointer to the remote service, presumably an IP address, some other information so you can send packets to it. The scheduler stuff, I think we saw the header, server, pivot, and we'll look at all this, I guess. These are different transports, TCP, WIN, HTTP, WIN, HTTP, WIN net, thread, zlib. Why zlib? I don't know. So in metserve, we have the core header, which has some packet stuff, some TLV stuff, so like communication, packet transmission, transmit response, transmit, etc., completion handlers, and so on. So this is like for setting up the server. Maybe handlers are also used for like some automation stuff. And what else? We have list.h, and this is just list create, list destroy, and these are p lists. I don't know if p list is maybe like a pointer list, but these are maybe like linked lists or something that we're maintaining. Server pivot, we have the ability to add pivots and remove pivots. And here's the C implementation, the C file. And when we call request core pivot add, it calls request core pivot add named pipe. And we can remove. Remove is harder. We'll call pivot tree remove, and so on. Okay. We have this base inject.h, and it supports 3 injection techniques: remote thread, migrate technique remote thread, migrate technique remote thread wow 64, migrate technique APCQ. I don't know what APCQ is. Asynchronous procedure calls. So basically, like an RPC, except asynchronous. All right. So somehow we're going to try to inject using these things. Like thread, I am guessing is, well, I don't know. I don't know what the, it's going to try to implant your DLL stuff into some running library. Definition of NT DLL bang NT Q APC thread. It takes a thread handle, an LP APC routine, I guess a long pointer to an APC routine, a routine context, and a status block and some reserved stuff. And then this is just kind of like all set up. The APC context has a start address and some padding and a parameter and some padding. This is a union. And I guess whatever, I don't know, be executed is, maybe that's a Boolean. And then this is some struct that's used for the WAL64 stuff, whatever WAL64 is. And this is just the headers. Let's see if we can see what methods are called when we actually try to implement. Okay, so these are like actual like payload things. CMSF3/external source shellcode migrate execute 64.asm. So this is some assembly fixed an elusive bug on AMD CPUs. Blog rewolf.pl, this thing. Found and fixed by Rewolf, incorporated by Ram Michael. So that's, I guess, some just attribution. So you somehow inject this assembly, and that's going to cause problems. Loading the SS register with a move instruction inhibits all interrupts until after the execution of the next instruction. This operation allows a stack pointer to be loaded into the ESP register with the next instruction, move ESP stack pointer value, before an interrupt occurs. Be aware that the LSS instruction offers a more efficient method of loading SS and ESP registers. Okay, so this is monkeying around with the stack stuff, which is what you want to do if you're injecting some stuff. And these are all like different like known attacks that other people discovered, and we're just kind of using them as like routines to inject some code. What code are we injecting? Well, presumably the Meterpreter shell, so that we have shell access. And those are I guess the three types correspond to the three attacks we have, like APC stub x64, APC stub x86, migrate WAL native X, and migrate execute 64. And then the actual implementation, I think once we know that these are using existing exploits, I think the actual implementation is probably not so fascinating. Channels, I'm going to guess is mainly just for communication. You kind of have to implement it if you're going to implement the server. But other than that, there's not, I think, so much fascinating here. Metserve. This should be the main entry point. We have this extension struct, which takes a library, which is a module, an H module, whatever H is, some init stuff, some dinit stuff. I guess these are the things that a module has to provide. It has to initialize itself and deinitialize itself. We have command added, which I think is different from add commands, and then some command start and ends. And we have a server setup function. And it's going to open up some transport, right? So we've seen how the encoding is done. It has this TLV stuff, which I think I'm going to think of as similar to ASN1. We're just sending essentially some like opcodes. How long is the payload after it? And then like, what is the value? And this can happen over TCP, HTTP, HTTPS, or a pipe. And then here's the server init stuff. We're going to init logging, init app instance. If h app instance is still null, that means we haven't reflectively loaded. So we must patch the h app instance's value for use with loading server extensions later. And then we're going to switch on the, whoa. We're going to call server setup. We also handle exit func directly in metserve now because the value is added to the configuration block. So this is some, this is just going to set up, I guess, the exit function. No, somewhere I missed an infinite loop. Is it server setup? In the case of metserve payloads, the parameter passed to init is not a socket. It's actually a pointer to the metserve configuration. So do a nasty cast and move on. All right, I don't know what a nasty cast is. And then you get some result. And where is result used? But if we're down here, it says we're exiting. And we return the result, I guess, at the break. I don't know how we get down here. Oh, I guess like we may call exit thread and then break, and then we go down here. This is DLL main. I'm guessing it's going to do some of the DLL stuff. Current Unix timestamp is, I'm going to assume, gets the current Unix timestamp. Here's some XOR stuff, XOR bytes. With a key. This looks like a naively implemented crypto routine. Is that good enough? I feel like you should probably use an existing stream cipher. Is this really what it looks like? We're just going to XOR. All right. Well, I don't know if that. I don't know if naive is good enough for stream cipher. But I don't know, we'll find out. Okay, so this is some rand XOR key. This is just some random key. Okay, so let's ask Gemini. What do you think this XOR key, this XOR with a key implementation? Its strengths are the simplicity and efficiency. Weaknesses: weak key strength, short key length. Using a 4-byte key is relatively short and can be easily brute forced. Repetitive key usage. The key is repeated cyclically, which reduces the effective key space. Lack of cryptographic security. XOR is reversible. XOR is a reversible operation, meaning the original data can be recovered easily by applying the same XOR key again. Susceptible to known plaintext attacks. If an attacker knows a portion of the plaintext and the corresponding ciphertext, they can easily derive the key. Poor randomness. Using time null as a seed for the random number generator is not ideal, as it can be easily predicted, especially on systems with low clock resolution or time synchronization issues. Limited randomness. Generating random numbers modulo 254, I didn't even notice these things, limits the randomness of the key. Huh. Why? So why would... what are they doing? Obfuscate payloads with XOR encryption. Yeah, I don't know. I'm not going to be able to find, I think, a good answer to why they're doing this. Why don't they have like a real cipher? I don't know. I can't imagine an application where you are attacking somebody's machine and you don't care about, We care enough about cryptography to like have a little bit of it, but not a lot of it. So that seems to be what they're doing. The Meta API header has nothing. We're just going to move on from the crypto question though. The Meta API.c. This is just API stuff. We're like listing all of the methods that we saw before. They're in a big struct. And that's how it is. This, we're going to ignore pivot dispatch. Here's the implementation of the pivot dispatch stuff. It takes a thread, dispatch thread. So it takes some thread. We're going to ignore the debug print. It says dispatching packet on thread, whatever. So we'll take the thread, get its parameter 1, cast it as a pivot context star. Hopefully we know that somehow that's its type. I don't know why we don't have it more strongly typed. And that gives us a pivot context. And then we'll create a packet buffer by taking the parameter 2 and casting it as an LP byte. And then the packet 3 is the packet size. So this is a parsing routine really, but it's not really like a type safe parsing routine. And then we're going to call pivot context packet write, passing the state, the packet buffer, and the size. And I don't think I'm looking to look at it any more than that. Remote is just, we have this remote allocate thing, which creates a remote. Do you have remote.c? Yeah. So remote allocate, we're going to allocate some stuff, instantiate a remote context from a file descriptor. This function takes a file descriptor and wraps it in a remote context, which makes it easier to interact with the endpoint. Okay, so we just have a file descriptor and we're going to wrap it in our own juices so that we can use it more easily. We have some lock. We have an enc context, which is null. Again, I don't know if enc is encryption or encoding. And we have some pivot trees, which now we believe are real trees, although the struct between the head and the branches are in different folders, which is a little bit unusual. And if we have remote pivot sessions, whoa. So I guess if we're done here, then we're done doing stuff, right? So this is some infinite loop. We're going to do while 0. And the thing that we're doing is we're going to lock, set the context to null, create a new pivot tree in an infinite loop. I'm not sure why. And then return remote 0. I guess maybe we're doing it in a loop. While 0. Oh, 0 is false. Right? So why are we doing that? At any rate, if we're down here, if we have a lock, we're going to destroy the lock. If we have pivot sessions, we'll destroy the pivot sessions. So this is cleanup, and then we're going to return null. Let me ask about this code. I feel like I'm missing something. Tell me about this code. So wrapping the code inside a do while 0 loop is a common idiom used to allow break statements. Did I miss a break? Oh, it did. Yeah, okay. So, okay. Yeah, all right. So if your mode is null or the lock is null, then we'll break. Okay. For early exit within a single execution block is also often used in macros. Is that just to allow jumping? Why not just say if not remote or not lock, or the reverse? If remote is non-null and lock is non-null, then do this, and then we would get a return. Otherwise, if we have this null stuff, then we okay. So if we have null stuff, we check if there's a lock, in which case we destroy it, because we know that we know I guess that there's a lock, but remote is null. But if we're down here, then we know that there is no lock, so remote must be non-null. And so we clean up the remote because it doesn't have a lock or something like that. That's kind of weird. So it's missing return statement on early exit. If either remote or lock is null, the code breaks out of the loop but doesn't return a value. Consequence, if this code is inside a function that expects a return value, failing to return a value leads to undefined behavior. While the do while zero construct is acceptable, it's more commonly used in macros. In functions, using if statements or early return statements can enhance readability. Okay, so it's kind of a crazy and strange thing to do, but I guess they do it. We have this remote deallocate. All right. So here's scheduler. We can initialize it, destroy it. I think that maybe I opened the C file. The headers here are not so informative. In other projects, they're super informative. So remote has a pointer to the remote. We have a waitable handle, some events for pause and resume, a context, I guess whether it's running, the routine, and destroy. Schedule or initialize. It's going to call list create to get this to create a scheduler thread list. The scheduler remote is set to the remote. We can destroy the scheduler, but what else can we do? You can insert a waitable. Insert a new waitable thread for checking and processing. So we're going to allocate a waitable, and then somewhere we'll set some entries for it, and then we'll call thread create and check that it's not null. You can signal a waitable with a scheduler signal. It doesn't so far seem to be doing any scheduling. It just seems to be holding threads. The scheduler's waitable thread. Each schedule item will have its own thread, which waits for either data to process with the thread signal to terminate. Okay. So I guess it's either just waiting on data or waiting for a termination signal. But I don't really think it's necessarily doing any scheduling in the sense of like deciding what to run at which time based on some sort of like optimization algorithm. This is stuff for adding pivots. I think we've already seen this. We'll ignore it. The thread has a length. What is this? These are object attributes. But whatever this is has a root directory, a length, and object names, some attributes. And I think this is mainly just going to be an ordinary thread. You can send the thread a sig term. You can run a thread. You can kill a thread. And here's the metserve.c thread. And that's mainly metserve. So what does that leave us with? Well, we have this screenshot. I guess it might produce a BMP and we'll convert it to a JPEG. I'm guessing this is just using the screenshot API on Windows somehow. Screenshot send. Send a buffer to a named pipe server. Here's the screenshot actual function. You might get error access denied. We have this Windows station stuff. I don't know what that is. Some X and Y metrics. These are, I guess, where we are on the screen. Also, X and Y position. I don't know what SX and SY are. But so we're going to open Windows Station A. And I'm guessing that somehow this is going to enable the screenshotter. A Windows Station contains a clipboard, an atom table, and one or more desktop objects. Each Windows Station object is a securable object. So whatever that Windows Station is thing, set process Windows Station, set thread desktop, and so on. Get system metrics, getting the height and width. The bit BLT, so bit blit, I guess the screenshot of this session default input desktop to on when stay 0 onto the memory DC we created. Okay, create the bitmap is we're going to call create compatible bitmap, passing in the stuff that we got from like asking it its size and stuff. Create compatible DC. I don't know what a DC is. get desktop window, compatible DC, compatible bitmap, Windows, screenshot. Create compatible DC function. Creates a memory device context with the specified device. I'm guessing the device in this case might be the screen. Create compatible bitmap. Creates a bitmap compatible with the device that is associated with the specified device context. I'm guessing that this is essentially what the screenshot function. So I think this is just calling Windows APIs. That's what you would kind of expect. MingW include this is probably where we get things like ls and like change working directory. We saw the TLVs for how those were sent. I'm guessing that perhaps the implementation is via the MingW stuff. Let's search for chmod. Well, we have this is Python. We'll ignore that. Common command IDs. That's just the command IDs. Command.py. That's just the number. Python again. Ext server. This is PHP. This is some JPEG reference. Python modules. More Python stuff. I don't know. Maybe everything is I'm guessing that that's what's really going on, is that the MingW stuff has somehow the new commands, and then those are mapped from the names of the TLV stuff that we send, although I'm not seeing it in the code. That could be just because the regex I'm using to search is not the right thing. This is metserv. We've already seen metserv at this point. I think we can safely ignore JPEG 8. We've seen elevator. And I think we've seen just about everything. Should we take one more look at MingW include? What if we do a search for MingW? There's some CMake stuff for it, and I'm not sure. They seem to use it in the extensions. Maybe it's only using the extensions, I don't know. We haven't looked at too many of the extensions. I'm sure that a lot of the functionality is actually in the extensions. But we've looked at, I think, enough to have a sense of what is going on with Meterpreter. We're going to inject ourselves this shell into a remote process. We're going to ideally migrate to another process that has admin privileges. From the admin privileges, we can escalate to local system, so that whatever the system privileges are, and the way that the server works is the server is pretty flexible, and we're just sending like a really simple data stream of like commands and arguments, and possibly just XORing them with a key that's really weak. But I think there's other encryption stuff in there. Like we saw that there was like some public key option, and that's really how it works. And then kind of what this is doing is it's putting together a lot of known attacks that have presumably been used for a while, and then somebody was just like, let's write them down. Let's make them easy to use and apply, and have like a standard way of doing this, rather than kind of like setting something up custom every time. And I think that's usually how stuff like this evolves. So that is Meterpreter. This, again, was a viewer request. Requests are done by donation. So if you wish to help out the channel, you can become a patron on Patreon. You can send some super thanks on YouTube. You can join the Discord and also check out some of the earlier stuff we've done. We've looked at the Metasploit repo as well. This was a kind of particular sub repo within Metasploit that was focusing on the Meterpreter shell. And there's lots of videos that we've done looking at different open source projects, from compilers to windowing systems, bootloaders, all of the different things, all of the different parts of your computer, some parts of the Linux kernel. So if you're interested in that stuff, check out our other videos. Thanks for watching.